All right, guys, I believe maybe each and every one of you is able to see the screen clearly now. Are you good on your side, Feb?
Yeah, I'm good. Can see clearly. Thanks, Newton. You can go ahead.
All right, thank you. In this session where we're going to be discussing, guys, we're going to be discussing two topics, that is confined space and isolation. The aim of the Zoom session is to give an understanding of the basics or fundamentals as to what we are expected of and what to look out when working in confined spaces and when doing isolations. At the end of the session, myself and Fabian will respond to the questions that will arise during the course of the Zoom. So feel free to send in your questions as we progress. We'll begin by confined space and then we'll go on to isolation. There are two pictures that I've shared there. The confined space is there. The one on the left, far left, is a gentleman there who's trying to assess a confined space where he's going to be conducting his work in there. So these are the type of things that we're going to be looking at and talking about. That the metal that is around that gentleman there, the one who's inside, is a tripod that is used to lower the person inside. Actually, it's just a device that has got a winch, which you connect a harness on, and then you lower yourself going inside there. It is used as a means of retrieving a person from a confined space should somebody get trapped in there while it's in the process of working. And that's the confined space as well that on the picture on the right that we're going to be getting into details with. So I'm just trying to give you, and some of us who maybe haven't gone into the confined spaces, what the picture looks like. On the far right there, where you have your connection point logo, there's a gentleman there in yellow who's also entering a confined space. Those type of confined spaces are the type of confined spaces you would find in especially in oil and gas and in silos and such related industries, where one goes into the tank through an opening which is called a manhole, where that gentleman in yellow is entering there. And in these spaces, most of them, you are required to get in there through the permit to work system, which then is a system to allow you to go and work or to carry on, to carry your activities inside the confined space, as there poses a lot of danger in confined spaces. So hence the reason why I decided that maybe we might share a little knowledge we have in the industry regarding these confined spaces, which most of the workers have died in these places as a result of either negligence or lack of understanding. Let's get on to our introduction. In many companies, especially in oil and gas and chemical related industries, confined space entry has been made a golden rule. These companies, what they regard as golden rules is it's a set of rules that they have come up with due to so many things that has transpired throughout the years. The learnings that they have got through and the recordable incidents and accidents. So the higher the number of these accidents and incidents made them to sit down and say, hey, there is a gap somewhere within the system. Let's create some rules which will abide to, and all the contractors and everybody who comes to our premises will abide to these rules. So hence they created the golden rules. So if you go to some companies, you'll find out that there are a set of rules. Whether you're a visitor or you work there, you have got to abide with those rules. So you can have a set of 8, 10, or 12 those rules basically. So why the rules? This is all because of lives that were lost since the confined space became of existence. Up until the management and the board of safety to sit down and say, guys, something has to be done for the safety of the people working in the confined spaces. Regulations were formed and given to law enforcers, to companies and individuals. Like what we guys do basically when we get to site, we only take the law that is already there and we enforce it to the workforce, to the people, to everybody that is in the environment. So these laws were given to us for a cause that throughout the years, people have been dying, incidents has been happening in workplaces. So then that is the reason why we are employed in these places. Ever since the people has been gaining knowledge day by day, but the unfortunate part is that lessons learned, they were learned after fatalities and injuries. The main thing that makes a confined space so dangerous is that it kills people, and that which kills people while they're in a confined space is cannot be seen, cannot be touched. Is something that attacks you um, unseen. You cannot touch the gases that are in there. Sometimes you cannot even feel them. Some of the times you can just smell a little of it, and then the person passes on. So hence there are procedures and steps that needs to be in place for one to start working in a confined space. That is what we're going to be measuring into now. The definition of a confined space. A confined space is a place that is either enclosed fully or it is partially closed. So what we're talking about is you can enter into an environment like the picture that I've been showing you there, which is closed. They are enclosed fully, like those tanks, the oil storage tanks that we in the oil gas they do have, the silos. So they are enclosed fully. But some of the confined spaces, they are partially. Like for instance, if you dig a trench, your roof is always open because it's uncovered. So it's partially open, but it is regarded as a confined space due to the depth. So companies have got a way of classifying these confined spaces. Some, they will tell you that from a depth of 1.5, if you are excavating, that automatically is qualified as confined spaces due to certain reasons that they put in the document there. Because the main reason being, if you are working in a gasterous area, all the gases and vapors, they tend to find the lowest point of the ground. That's where you'll find them. So if you are to excavate and you have a trench, you dig your trench there. The reason why they regard that as a confined space is because now that you have created an opening that is deep, Fabian, can you guys still hear me there?
Yes, Newton, go ahead.
I can hear you.
All right, cool. All right, I was saying the reason why it's regarded as a confined space is due to the low point of the ground that you have created now. If you dig a trench, all the vapors that are around, they are not, because vapors, they don't go up in air. They find the lowest point of the ground. That's where they hide themselves in there. So if you are to excavate and then you're in a trench, that's where you possibly find your vapors in there. Hence, they regard that as a confined space. Even though it's partially open, the roof is open, but it's still a confined space. So some people tend to confuse these things like, okay, but I can see the sky. So definitely I'm not in a confined space. That is not the definition. So it can be partially enclosed, or it can be fully closed. Okay. Uh, in some instances, gases might be present or might accumulate with time. That is the other thing also that comes up with a confined space. It is a space where you get in. Sometimes there's no gases and there's nothing. The environment there is good. You can breathe in, breathe out, nice. But during the course of the activity, then gases arises in the process. That is one of the characteristics of the confined space. It is also characterized by the entry and exit points. It has got a limited entry and exit points. And in these exit and entry points, you need to have people guarding these so that when you're working in there, nobody gets in without the permission of the one who's in control of the area, which we're going to go deeper into later. The Confined Space Rescue Plan, I'm just going through the definitions now here. The Confined Rescue Plan is a document it's a plan that is set to identify the rescue procedure or the rescue measures set in place. It's a step-by-step document that will tell you, should this happen while you are working in a confined space, who's responsible for what, who's going to be the rescue team. And in this rescue process, you have your rescue team there, Mr. AB, Mr. whatever, those guys that you're going to be having there. And it specifies what each and everyone there does, the roles of these people. You also have the on-scene command that is also going to be part of this rescue plan. You have people who conduct this rescue. You have got the fire brigade. If you are going to have the fire brigade, you've got the police and everybody, the ambulance. You need to put on all the numbers, the contactable numbers for those people, should something happen while somebody is working in a confined space. So the rescue plan, therefore, is a document that comprises of a step-by-step of how somebody will be taken out or retrieved from a confined space should something happen. This document points out who is going to be the rescuer, how the rescue is going to be conducted, the rescue apparatus or equipment, that is the rescue kit, the stretchers, breathing apparatus, and all that. And also it states the expected time of the rescue, taking into consideration that the longer the casualty stays in a confined space, the more riskier it is. That is a very crucial thing when it comes to confined spaces. The rescue time, it is very important. So if you're working in planning to work in a confined space, you produce this document to whoever is in charge of the area. Say you're contracted to BP, Shell, whatever the company might be, these companies that have the confined spaces. You submit this document with also the other document that supports the confined space system. When you submit this, the HSE officer responsible for that place will go through this document and approves of your plan. And this plan, he or she must not just say, I'm not approving of your plan. There must be valid reasons if they disapprove, and they must tell you where to correct if ever there is any missing information on the document. So in this, that's where you find your in this rescue plan, that's where you find all the things that needs to be done when conducting the rescue. The crucial part that I wanted to talk about is the rescue time. If a person is inside a confined space due to gases that accumulate in the space, time is of essence, because the more the person stays inside there, we don't know whether this person is collapsed or whatever has happened. We don't know what what actually made this person to collapse. So we need to identify, if you've got a monitoring system that is the gas monitor will say, it will detect the gas that has made this person to collapse. But before you even get to the person collapsing, there are measures in place as to avoid such to happen. Like you have your gas monitor, you have a guy who's going to go in before you get in to start working, and you have the gas monitor with you so as to continuously monitor the air inside there. The person to be rescued in a confined space, in most cases, if you are working for a certain company, if you are a contractor, you have got to provide your own rescue team. In most cases, that's what they do. So the company that has contracted you, which is your client, will take over when you have taken the casualty out of the confined space and by the entry point, then they'll take over from there. That is why they need your confined space rescue plan. What are you going to be doing if something happens whilst your men are inside a confined space? So you provide this document so as to show the client that, okay, I know what I'm doing here, but should something happen, unforeseen circumstances, probably maybe the gas detector could not pick up these gases due to certain reasons, because the gas test has got a filter that filters the air. If that is dirty as well, it might gives you false readings. So that might be the case, and maybe this gas monitor did not pick it up, and then the person end up collapsing inside the tank. But prior to your activities and everything else, all these things will be checked. So, but you just take the worst case scenario to say, this is what happened. A person was working inside a confined space, and should something happen, I'm going to cover myself and my employees with this rescue plan. I'm going to do A, B, C, and D. So hence the reason why you submit it prior to your start of work. There will also be drills that will be conducted during the process of working in a confined space, so as to test the plan that is in place, how effective it is. So once you're working in there, you start working, the client might just sound the alarm as a sign of there is an emergency. Everybody needs to evacuate. Or they might come to you and say, can we make our way into your confined space? Then by all means, then they've got the full rights to get in there. Maybe they want to do an inspection or whatever they want to do there. They'll fill in the register, do all the necessary procedures that they need to do before they enter into confined space. And once they're in there, in so many scenarios, one gets in there and collapses himself or herself just to test your plan, how your rescue plan is effective. Then from there, it's you also and your team who's supposed to take this casualty out. So it will be a scenario whereby it's not real, but it's acted real, so as to test the plan, how effective the plan is, the one that you have in place. So then you're supposed to conduct your team. The guy who's outside is the standby person will sound the alarm, and okay, if the alarm is already went off, it's fine. You just conduct the necessary people, and then step by step call the rescue, take the stretcher, get inside there. If they need, in most cases, then because you don't know what made this person collapse inside confined space, you'll be required to put on your BA set, which is the breathing apparatus set. Then you can get in there and evacuate the casualty inside the confined space. So the confined space rescue plan consists of so many things, and that is the main document, actually, I can say, when you are working in a confined space, we have got to look so much deep into, because once your plan is not so effective, then should something happen, you are bound to have maybe a loss of life or serious danger, or your people might end up not being able to come back to work due to certain reasons, like if one has been exposed for so long in a confined space, you cannot just go back to normal within hours, within days, because normally it affects your respiratory system. So you need days off, you need some time to regain yourself. Then let's move on to confined space risk assessment. This is a document that all your hazards identification are done. And once you identify these hazards, it's just like the risk assessment, the normal risk assessment that we know. But this one measures more in the confined space itself and the tasks that you're going to be conducting in there. Because bearing in mind that before you start any activity in a confined space, it has already its own hazards as it is before you start even working. So it comes up with its own hazards. It's a very dangerous place before you even enter in there. And now when you get in there conducting your activities, you are adding more to what is already there. Hence the reason why we need to risk assess. We need to have this document so that we can check what's in the confined space. What was it containing before? If it was containing petrol, if it was containing whatever is like, especially more of chemicals, can I come in and start grinding in there? If the previous product or previous thing that was in there, is it combustible? Does it catch up fire? Or Febs, is that you?
No, that's not me.
Oh, okay. Guys, can you please try to mute so that maybe we can have the clear sound, and then once we open up for questions, and then we can unmute and start communicating. So we are still on risk assessment. The reason why we need to risk assess is a confined space comes up with its own hazard. So when you enter in that environment, it's already hazardous. It's not like most of the places where, like, okay, you walk into an office, there are hazards in there, but they are at a minimum. These ones, they already have the maximum hazards. When I'm talking about the maximum, I'm talking about they are very severe. Should something happen, you are bound to have a fatality or serious injury. Whereas it's different to somebody who's walking into an office where you know that, okay, the risk or the hazard that you are having there is to fall over maybe something that um, there are computer cables or whatever maybe on your way. Here we're talking about serious gases. We're talking about things that can explode. So hence the reason for the risk assessment. You need to risk assess these things. If you're going to be welding there, then you'll be adding to the hazards that are already there. So you need to check, like I said, on your risk assessment, you need to assess not only from the point of where you are, but from the previous records of that confined space. What did it contain before? Because now remember, when you're going to work in a confined space, you are not going to be working in a confined space which has got already product or something in there. The product has been cleared and everything else has been out, but then you are to go in there and work. So you should know what was in there before, so that your activity will not contradict or violate whatever was in there, and you find yourself in danger. It also states how these hazards are going to be mitigated. When conducting a confined space risk assessment, one has to bear in mind that it must cover even the surroundings of that confined space, because some of these hazards, they are not inside the confined space, but due to where the confined space is, it might be that the outside environment might also impose danger to the person who's the entrance into the confined space. So you need also to risk assess outside the confined space and check, okay, if you're going to be entering a confined space that is underground, say for instance, it's a manhole that is underground. These manhole, they've got manhole covers that under normal operations, it's a road. People are walking, are driving over that. But now that you are working, you need to put solid barricades around your manhole so that nobody drives in, and even people themselves, they're not going to get into your confined space uninvited. So you need to put your barricades. Those are the mitigations that we're putting in place now, so that nobody gets in your confined space uninvited. Remember, like I said, it might be on a driveway. So everybody who has been using this road or this driveway every day knows this road or this driveway as a driveway. People might come driving there. So you need to put warning signs before you get to this, because somebody might come up speeding, and when they try to hit the brakes, they're already in your confined space. They're already there, and they will find themselves, you'll find yourself in trouble. So you need to, signage is very important as well when you're working in these, especially the underground confined spaces, because you need to warn people of danger from a distance, not just right where you are. So you need to put all these in your risk assessment. How are you going to control the environment for all these people who are not included in your activity? So these people you must create a safe zone where people will be walking, not inclusive of your space. Otherwise, you must own your territory there. If you're having a confined space like the one that we're talking about now, the underground, you need to put your barricading around at a distance from your manhole, so that nobody comes closer, and everybody who's working in there is protected. Also protecting the general public from entering into this zone where they are not invited, because they do not know the dangers of what's in your space. And what I've seen mostly is you might have barricaded and everything, but people, especially the general public has got a tendency of walking into spaces like that. They want to see, they want to know what you're doing in there. So if it's a hazardous area, which maybe probably might accumulate gases and stuff, you cannot have people coming and peeping into whatever you are doing in there. Oh, what's in there? What are you guys doing? Hence the reason why now you need to put your solid barricading around. It is a requirement when working in these spaces. In this document, this is where you are going to risk assess all your activities or work to be carried out in a confined space. Like for instance, you're going to be welding. If you're going to be doing welding in a confined space, like I said, you're already adding something to what's already there. Bearing in mind that the oxygen that is in a confined space is so different from when you're outside a confined space where we are just breathing in and out normally. Even if somebody passes where you're outside of a confined space, a car that is smoking, or maybe somebody who's even a smoker is smoking 2 meters away from you, that smoke will quickly disappears into air, because it's the whole amount of oxygen that is present in the air against the small carbon dioxide that is produced, or whatever monoxide that is produced there. Hence, in a confined space, your space is contained. If you smoke in there, your smoke is just going to be in the air here, and it's going to be eating up the particles of oxygen that is already in the air, therefore making this space, making this oxygen that is already in the air less and lesser. So same applies when you're welding. If you're welding in a confined space, you are slowly taking up the oxygen that is in the air. So in your risk assessment, you need to state all these when you are risk assessing your activities. What are the steps and in your welding? What are you going to be doing? How many welders are you going to have in there? And have you checked the space that can it contain these welders in there? Your lighting also. Can your people, while they are working in there, can they clearly see? If ever you need to put some lights in there, in most cases, they have to be intrinsically safe, which means lights, these are the lights that you need to have in spaces like that. They protect you from certain, because there are certain lights that we use under normal conditions, that if you use them in a confined space, they add more danger. Hence, we encourage that you use the intrinsically safe devices. Whether you're going to use a camera, it has to be intrinsically safe. Whether you're going to use a two-way radio, those are the type of devices that you need to use. In most companies, they've got a green sticker that they apply, they put on to mark them as intrinsically safe, to say these are the ones that are allowed in confined spaces. All right, let's proceed to the standby person. This person's duties are to record the ins and outs of the confined space entrance, to keep a constant communication with the entrance by the means prescribed on the confined space plan, to alert the relevant parties or raise alarm should an entrant be trapped, injured, collapsed, or in need of rescue. This person is very crucial in all the activities of a confined space. Without this person, people can just walk in and walk out of a confined space uncontrolled. So this person controls the confined space itself. He or she is the one who records your name when you get into confined space. The reason being, should something happen, we need a record of the people who are still entrapped inside the confined space and the people who have went in and went out. If we are to conduct an incident report, we need to know who was in there, who was out. And when these guys were in, by this time, were the conditions still favorable for the workers to work in? All those, that is why we have this person, the standby person. His or her documents helps us to get to the core heart of what happened and what transpired during what time this happened, and mainly because what could have been the cause. So this person, because he or she records the ins and out of these people, he is or she is in constant communication with these people. In some ways, you've got a two-way radio where this person is outside a confined space and is talking to the people who are inside just to check on them. If they are still fine, then they respond over the radio. In some instances, there is a rope that they use. I shake once the rope whilst I'm outside as a confined space standby person, and whilst you are inside, you pull it twice as well. I pull it once and you pull it twice whilst you are inside there, just as a signal to say I'm still fine. So that kind of communication is very important, because if you pass out in a confined space, you need to get emergency response at that very moment. Otherwise, you're gonna pass out and die in a confined space, because the gases that accumulates or that in confined spaces are very dangerous, that they can cause a fatality in minutes. So there are some points that I've made here, that if you are going to be in a confined space, you may not be in a confined space unless you have checked these points that I've written here. Point number one, that there are no practicable alternatives to enter. If you are going to have an activity in a confined space, you should have checked already that is there anything else that you can do without entering a confined space? Unless then it becomes a necessity for you to get in there. That's when you can go in and conduct your activity. And in most times we encourage that let it be as short as possible as you can, not to be prolonged. But if you are going to have a project while you are working inside a confined space, then it's fine. But all these should go according to the documented prescribed plans. All sources of energy affecting the confined space are isolated. If you're going to be working in a confined space, maybe some of these things we're going to touch base on them on the isolation. I'm just checking my time here that maybe if we're going to do isolation, we're just going to do a bit of it due to the confined space that I wanted to emphasize some of the points on. So when you're getting into a confined space, all the the supplies of that confined space must be cut off. That is isolation. If it's a confined space, that is a storage facility for whatever it stores, then the point where they receive into the confined space, which is called the input, and then there is an exit of that product, which then you have your output there, the input of the tank and the output, where you're going to have the receiving end and um, the receiving end of the product into the confined space or exiting the confined space. Both sides has got to be isolated. If it's a product that is, say for instance, gases, liquids, things like that, you need to positively isolate, which is you need to take out a spool piece from the main supply of the line that supplies that confined space. You need to take out a piece of the pipe, take it out completely, blank it off, so that there is no continuous supply that goes to that confined space. And before your people start working, this area also must be cleared. It must be well ventilated before you can put anybody into a confined space. So what happens is you isolate and you let that confined space vent for some time. It just vents on its own if you open the manholes for some time, up until a certain time where you can go in again and test and check if it is suitable for you to send in your people for work. The confined space atmosphere is tested, verified, safe for occupancy, and repeated as often as determined by the permit. This is if you are going to be working with the permit to work system. All these will be prescribed on your work permit. In most cases, the confined spaces have been made in such a way that it requires a permit so as to have a control system of what goes around in a confined space and what happens in there. Because it's not everybody who comes into this environment fully equipped with the knowledge and understanding of these confined spaces. So hence the permit system assists you to, it actually reminds you to say, hey, have you done this? Have you done that? Check A, B, C, and D. All these things that you need to do, they will be verified on the permit system. So unless you do this, you cannot enter a confined space. The hazards, risk, and controls in a confined space entry permit are communicated to all affected personnel. Before you put in your people in there, you need to communicate your risk assessment. You need to communicate your precautionary measures that you're going to be putting in place to your team that you're going to be working with. You need, when you're going to send in the guys in a confined space, they need to be fully equipped with all the knowledge, relevant knowledge that they need to have in pertaining to the place that they're going to be working in. A standby person is stationed at the entry point and maintains communication with entrants during the time occupants are inside the confined space. We have touched based on that one. A plan for time rescue of workers in a confined space. We have already spoken about that one as well. So these are just the points that you need to check on before you get into a confined spaces, into a confined space. That is why I put them here. Some of them they are repeated. A confined space entry permit is issued. That is in places or companies that uses the permit system. Unauthorized entry is prevented. So if you have checked all these points and you see that you qualify under all these points, then you're good to go in a confined space. You can know that you are, at least you'll be safer in that place, and your team also can be safe. Gas monitoring, which is a vital point when it comes to working in confined spaces. When working in a permit-based confined space, certain things need to be obtained before work commences, and gas monitoring is one of the critics. Gas monitoring is normally done by the permit issuer. Like I said, most of these confined spaces, they fall under work permit kind of schedules and jobs. So a person who's going to be issuing you with a permit normally is the one who's also going to be doing your gas testing. It simply means that this person goes into that confined space, test that space for you, the oxygen levels and everything, and write on the permit to say, I've checked at 7 o'clock a.m. This confined space is in this state. Your oxygen must be around 20.8. So this person records it on a documented, prescribed document there to say these are my findings in the confined space. If then it falls within the range of a safe range that is allowed for a person to go into a confined space without breathing apparatus, you then write on the permit to say, okay, I've checked the oxygen levels and everything else within the confined space and around the confined space. Everything is favorable for a person to go and work in there. But on that same note, you need to have your own device, which is the gas monitor, that you carry and go into the confined space with. When you're working in there, your monitor, you don't have even to keep on working without checking it. You work and you check your gas monitor. The reason why you check your gas monitor is so as to check the oxygen levels in that space if they are still favorable for you to be in there. But in most cases, these gas monitors, they they've got an alarm system that should something happen, the environment is no longer conducive for you to be in there. It will give off an alarm. Then once the alarm goes off, then you know you must evacuate, you must get out of that confined space because something is wrong somewhere. From the people who have the knowledge of the gas testers, then they will check on the gas tester itself. It will state what gas did it detect in there while you guys were in there. We have had incidents where, in my previous experience, we had a project manager who had the guys in a confined space, and because he's a project manager, he's working against time. You know how these guys can be at times. The guys are working in there, and the alarm goes off. They were welding. He had about 3 or 4 welders in that confined space. It tells the guys to reset the gas monitor, and the guys resetted it. I'm sure that was under fear of this project manager because he's the main guy, he's the big guy. He's this type of these guys that can fire you at any time. The gas monitor was resetted 3 times up until somebody says, hey, I cannot take this anymore. So he came out of the confined space and notified us as the HSE and said, this is what has been happening. The guy was dismissed on point. He could not carry on with his duties, this project manager guy, because he had violated one of the confined space rules, which is if this gas monitor goes off, you are to evacuate people. In some instances, you may not even be able to carry your tools and your equipment out of that confined space. You just have to go out. Because remember, one of the characteristics of a confined space is it has got limited entry and exit points. So you can imagine if you keep on resetting this thing and still, this is a safety device that you only have in that space. It's warning you that, hey, you need to get out. This environment is no longer favorable for you to be continue working, but you still put people again in such a space and say continue working. That cannot be tolerated. So if only he just paved his way out of the company by doing so. In any case, we have situations like that where even if we provide adequate knowledge and trainings, people still get ignorant when they get out there. Hence, that's behavioral thing. So should you be working in a confined space, these are the things that you need to be on the lookout for. If your gas monitor sounds an alarm, then you need to evacuate the place. Guys, I'm checking my time now. It's 11 minutes to 11, and we have a little time. I think we'll just go quickly later into the question and answer, so we can let me try to rush it a bit. So as for today, let me just try to cover the confined space, and maybe if time allows sometime, then we can go into isolation. All right. Gas monitoring is normally done by the permit issuer, as he or she needs to make sure that the confined space is safe for work before anyone gets into a confined space. If he or she has done the gas monitoring inside and outside the confined space, then he or she records the results on a gas monitoring sheet, which then allows him or her to give recommendations as to can the entrance go into the confined space with or without the BA sets, which is the breathing apparatus sets. There is a score ranking. There's a score ranking which the permit issuer records on he or she records the percentage of air that I was talking about, that normally the air that we breathe is around 20.8. So there is something that goes on in a confined space. Either your oxygen can be less or can be more. It can be less, or it can be, the place can be oxygen enriched. Then it's no longer favorable also for one to be working in. Common confined space hazards. There is toxic atmosphere. A toxic atmosphere may be caused due to various acute effects, including this can cause impairment of judgment, unconsciousness, or even up to a fatality. You can have death due to this toxic atmosphere. A toxic atmosphere may occur due to the presence or ingress of hazardous substances. These substances may be present in the confined space for various reasons, such as remaining from the previous process or storage. Like I was saying previously, that whatever the confined space were used to contain before, that can cause also the space to be toxic. Arising from the disturbance of the sludge and other deposits. The presence of fire or flames, like you are doing cutting and grinding, or you're doing welding, those things also can make the atmosphere toxic. Seepage from improperly isolated adjoining plants. This is where isolation now plays a part. Like I was saying previously, that you need to positively isolate before you get into a confined space. Formation during the work process is carried out in a confined space. Also, these things, you can get into a confined space and the place was favorable for you to work, but gases can accumulate, then it causes the environment to be toxic. Oxygen deficiency. Oxygen can be lacking in a confined space for the following reasons. Displacement of air by other gases. Like if you're going to have something that produces smoke in a confined space, then it will eat up the oxygen particles. Then you end up having the oxygen deficiency then. Various biological process or chemical reactions, such as rotting of organic matter, rusting of metals, burning, etc. Absorption of air onto steel surfaces, especially where the surface can be damp. Oxygen enrichment. There is an excess of oxygen. Like I said, your oxygen levels should be at the breathable percentage. If it gets too high, then it's no longer good for you. If it gets too less, then it's no longer good for you. Hence the reason why you have your gas monitor there to monitor these things. Flammable or explosive atmosphere. A flammable atmosphere presents a risk. It poses a risk of fire or explosion. These spaces, remember, they can explode at any minute if you just give them the favorable things for them to react. They will explode, and once they explode, they can cause so many fatalities. I'm trying to rush against time now here, guys. I can see our time now here is almost 6 minutes to. Okay, confined space hazards continued. Flowing liquid or free flowing liquids. Liquid solids can flow into the confined space, causing drowning. Hence the reason why you need to isolate, because these spaces, confined spaces, if you have your inlets or your outlets continuously open, the valves are open, and you did not blank off, you did not do anything, chances are that product or whatever might flow into that space and people can drown while they're still working in the excessive heat. You can remember, if you are enclosed in an enclosed area, which is a confined space, where there's no wind that is blowing left, right, and everywhere. So the heat that you're accumulating, the heat that your machinery are accumulating, and everything is just contained in that space. So also this causes excessive heat. The enclosed nature of a confined space can increase the risk of heat stroke or collapse from heat stresses. If conditions are excessively hot, the risk that this excessive heat imposes on us as beings is quite high. And that also need to be risk assessed when you're doing your risk assessment. If you're working in these confined spaces, you need to check also the temperatures within those areas. If you have worked in some parts of like Western Africa there, you know and you understand. Like I've worked in the regions that are like Gabon, where you have temperatures that goes to around 40s. So you can imagine, if you're in a confined space in such a heat, definitely you have to look around, and if possible, then you have to check your times, the start off times. Sometimes you have to even to work around nature. Where you guys are supposed to be start working is where you're supposed to be stopping due to the environmental reasons. So excessive heat can be very much, it can even cause a fatality in this. Right. In our next session, guys, I think we're going to be discussing about isolation. As for now, that's where our confined space ends. Fabs, Fabian. For those guys who have got questions, I think they can unmute and send in their questions, and maybe we can answer.
Sorry, man, I was just in another meeting. I'm actually on 3 devices at the same time. So thank you, Newton, for your time and effort. We really appreciate it for everything. Guys, please, if you have any questions, please pose your questions too, or raise your hand. And then we will acknowledge you, and then you can direct your question to whoever you'd like to ask.
as of now, guys, if you have any question, you can unmute, and if you have any comment as well, you can unmute and send in your comments, because that will be our end of our session today. Then maybe in our next session, we'll be going to be discussing about isolation.
Hi, Natalie here.
Hi, Natalie. Go ahead.
Thank you for the presentation. It's been a while since I've listened to Confined Spaces. Yeah,
Okay.
just reminded me of, how far I've drifted down the road. But yeah, it looks like the science is still the same in terms of how one operates. I just wanted to check. I did pose a question on tools and stuff like that in terms of using technology, because I have seen videos and stuff where they'll use, these robot cars, these cars that the kids play with, remote control
Yes.
vehicles,
Yes.
and also other sorts of electronic tools or videos that they actually deploy into the area to do the inspections mostly. So I just wanted to know how advanced are we in terms of doing that, based on the industry that you're working in.
Check.
Go ahead, Newton.
Okay. I'll comment based on two different, I would say, occasions. Here in SA, we're still doing it manually. I haven't seen in all these confined spaces that I've been to, whether I've gone there for auditing or for working, I haven't seen where they are using such devices. But I've seen those devices that you're talking about, not here, actually in Africa, somewhere abroad, because those guys, they are far much ahead of us. I don't know, maybe because Fabian now is in India, maybe in those countries like them, because India is also high rated when it comes to safety. Those guys, they do everything by the book. The reason being, if ever there is anything in a confined space, manually, you need to go in there and test a confined space. How we test this confined space is you go with your gas monitor. It has got a longer probe. So when you go to the confined space entry where you have your manhole, you throw in your probe, then it detects the gases that are close by. Then it gives you an option of entering if you are going to enter. Then you can check again further and further and further. Whereas these guys, they are advanced, they can just send a machine and just do this, so as to mitigate or avoid such cases whereby this guy who's testing can also be a victim of being taken by the gases in these spaces. Here in SA, maybe we might in the years to come try to implement that, but it comes with a cost. So most companies, they try and as much as they can to avoid such costs. Hence, that's why I'm sure we're still doing it manually.
Newton, if I may as well. Yes, naturally, there are some companies that utilize drones for this purpose. There are drones that have gas monitoring devices, etc., that are installed on them as well that you can utilize. So I know even from Cecil side, Quinton was on. Quinton Chetty is a safety manager there at Cecil. And I was hoping that he was still on. He could have also chatted with regard to it. So there's quite a lot of companies that are utilizing these devices. They're using drones a lot more within the industry, even for surveillance purposes, for inspection purposes, where they would have to build, let's say, large scaffolding, etc., to access into areas like cooling towers, etc. They're now using drones. So the technology is available. It is also available in South Africa. So you just got to find the companies that provide that service, but it is available.
Okay, so just as a final comment, what I want to say is that, remember I did the discussion on how to engage your senior management and your directors. Your responsibility then as a safety professional, as part of your controls, and I would say your non-negotiables, is to write that in your policies, your procedures, that you implement the hierarchy of controls, right? Because certainly this is a deadly job. You cannot rely on mechanisms that may become faulty, or detectors that don't work, or filters that are full of dust, or as is explained. I think the right thing to do is start moving away from the paper, the manual type of way we do things and think about safety, and start sort of enforcing our knowledge and our experience onto better platforms now, almost like a non-negotiable. So it means that the safety professional will have to do the research, because before this discussion, I actually read some articles. I just wanted to see where I was in terms of my knowledge. So I think you need to sort of step up the game and demand that management also thinks out of the box. But it will take a lot, because you work in a team and you've got to convince other people, especially if you come in as a contractor. So those things should then become almost part of your negotiating tools for this job that your company is taking on, or that you are taking on as a safety professional. But yeah, we need to do this together as all of us in the game. Thank you for your comments.
Thank you, Natalie. If I may just quickly, Newton, just to throw out one or two comments additional to what Natalie's mentioned.
Yes,
You know, a lot of companies these days are obviously trying to make their businesses safer or ensure compliance, but it all boils down to cost when it comes to clients. So when we sell our product to the clients, or when we conducting our bids, a lot of companies bring these ideas forward to companies, especially during bid clarifications, etc., and they promote it as let's say a selling tool to clients, to say, this is what we can do, or what we have, etc. This is the cost that it involves, or it entails, sorry. And many clients these days are actually choosing these safer options, these drone-like options, etc., or robotic options, etc. So again, it boils down to the cost. And if you make it as part of your process within a company, and say that we have a non-negotiable when it comes to putting our people's lives at danger, this is what we do, this is how we do it. Yes, there's an additional cost to it, but unfortunately, if you want us to do the job, then you're going to have to pay the additional cost that comes with it. But it's basically, as you say, Natalie, a non-negotiable. It's either you take us with this product, or you don't take us at all. But you know, the problem comes down to money at the end of the day. Many companies can't take that stance because of competition. They get outpriced because of these kind of situations. So, you know, it's one of those tricky situations. And I think that, yes, I think very soon we should be at that point. But again, it boils down to the oil prices and those things, which all have a knock-on effect on the industry and on safety as well. Because as much as many clients are safety conscientious, also boils down to the pennies, and the people that are making the decision are looking at the monies most of the time. So yeah, but valid points, and I agree with you. We need to drive this and try and standardize these kind of operations that makes it much safer.
Yes, thanks so much, Fabs, on that one. I've seen these devices, but I didn't know that locally we have companies already that are already implementing, which is quite a good thing. Very very impressive. You know, it's a high time that maybe we need also, as an industry, to catch up with the rest of the world when it comes to these high grades of safety. Thanks so much, Natalie, on that one.
Okay, thank you. Welcome.
Okay, thank you. Is there any other questions or any other comments before we end the session?
Yeah, Mr. Fabian, morning. How are you?
Hi, Innocent. How are you? Go ahead.
I'm good. Mine is not a question. I just would like to say thank you to Newton for the presentation. And the other thing which I noticed is that he was actually scared or a bit worried of the time. So maybe it should be a bit longer next time because it was so extensive. I really enjoyed it and learned a new thing from his presentation.
Thank you
very much, Fabian.
Thank you, sir. I think what we can also do is we can split it up into part 1, part 2s, etc., so that whoever wants to listen to the first part, whatever it entails, we can send that information out to the people so that they can decide which presentation that they would like to participate in as well. But yeah, thank you. Point noted, Innocent. We definitely.
You're welcome, Fabian. Thank you.
Much appreciated, Innocent. Thank you.
Okay. Just if I may, I'm going to take 2 minutes of your time quickly, just on this discussion. You know, we had a incident in Malawi. It was about 9 years ago. Guys were working, they were busy with rubber lining. I'm not going to mention the contractors that were involved for obvious legal reasons, but it's some companies that we know as well in South Africa that were involved on that project. So guys were working in a confined space. They were busy with rubber lining. If many people know about rubber lining, the product that is utilized is extremely flammable. So what happened was the mechanical company was busy within the location. They were busy grinding, and spark ignited the fumes that were enveloping from the top of the silo. And basically, I think it was 7 people that was critically burnt. 5 of those guys later died, and 2 of them survived with serious burns. So very, very important with regards to confined space entry, as well as isolation, and ensuring that people know about the dangers that they're exposed to. And as Newton rightfully mentioned, you've got to know the risks, the hazards associated with the task. People knew about it, but nobody really took it seriously. And unfortunately, people's lives were lost on that job in Malawi. So we need to take these seriously. And there's many cases of people passing away. I mean, guys will know what's happened, even if they've attended the inductions at Cecil, etc., with the amount of incidents they've had with fatalities caused from those in confined spaces. So yes, very well done, Newton. Once again, thank you very much to you and to everybody else that has attended as well. We really appreciate it. I just quickly see Samson's hand up before we close, and then I think we can close the session. Thank you. Samson, you can go ahead.
Thank you very much. I just want to take this opportunity to thank Mr. Ncube for the beautiful presentation. It was very informative. You see, one of the things that we always forget to do in terms of our hazard identification, in terms of working in confined spaces, is to actually go into details in terms of the procedure on how, if we have to introduce any tool at any given point. I'll make an example. Let's say, for instance, let's say, for instance, we are working with my goodness, why am I losing my thoughts? Sorry about that. Let's say, for instance, we're working in confined spaces, more especially, let's say, for instance, it's in a tank, or we are used to cleaning up the tank after we have we're working with a specific chemical. Now we have to change that chemical and put another one. So now you find that maybe without understanding what will be the effect of changing that tool that was prescribed, and you think maybe let me use a different tool without clearing and understanding the effect of the consequence of. So I think we also have to be specific in terms of the specific tools we have to be using specifically when we're working also under in isolation areas. And the other thing that we also have to also take into consideration all the time is the question of temperature, because temperature is very it's very important that we must always monitor it, because I remember one incident wherein they were working in a tanker. And then the one thing they didn't account for was the fumes over time of because of the temperature change. And then there was one person who ended up dying in that situation. So we also need to make sure that the temperature is always under any circumstances monitored. If under any circumstances we see that the temperature is changing, we must be in a position where we stop the activity with immediate. So I just wanted to add that that value as well. Thank you very much.
Thank you,
Thank you so
Samson.
much, Samson.
Thank you. Okay, I think that's fine. Thank you, everybody. Again, Newton, thank you very much for your efforts. We really appreciate it. Take care, everybody. Enjoy your day. Just to let you know that tomorrow we have Natalie's discussion, and on the 23rd we have Joseph's discussion as well that will be shared. Thank you very much. Please stay tuned.
Sorry, Fabian, you said tomorrow or Monday?
Sorry, excuse me. Sorry, Natalie. I'm losing my days here. Monday. Sorry, everybody. Thank you, Natalie.
Yeah,
The
thank you so
18th.
much, guys, for joining
I'm
in.
sleeping, eh?
It's been a pleasure hosting you.
Yes,
Fabian.
Joseph.
Bye.
Yes, Joseph. Go
Please
ahead.
tell Natalie not to steal my points, please, or otherwise I will cancel my presentation.
No, ours is on Monday. Yours is on the 23rd. So don't worry.
Okay.
Take care. Take care.